Hi, today I'm going to walk you through the Roots and Shoots lab provided by Kansas Corn Stem. My name is James Burk. I'm a lead teacher with Kansas Corn Stem. Today I'm going to walk you through the Roots and Shoots lab provided by Kansas Corn Stem. The purpose of this is to see how corn kernels figure out which way is up when they're underground, and to test some hypothesis, and it's very inquiry-driven activity that students can do. Materials, you'll need some pie tins, some potting soil, some seed corn, grow lights, and a record player or a turntable to spin one of your pie tins. So in this lab, I tend to start kids off with the phenomenon, asking them, does it matter which way corn kernels are planted? Talk a little bit about the precision ag and how spacing and things like that are important. This is a video that I shot, time-lapse video. You can do this in your classroom and allow kids to watch this happen, or you can use the video. It's on the website or the Kansas Corn Stem YouTube channel. And this just shows I planted corn kernels at 4 different orientations, and you can see them there on the video. And we're trying to figure out if they would know which way was up, or if it was important to plant them with the yellow side up. So this takes about 30 seconds to run through here. It takes about a week to 10 days to run this in class if you want to, but it's kind of cool to put it, plant 4 corn kernels in those orientations against the side of a glass container and watch them germinate. You can see the shoots coming up there now, so the one on the far right was behind the soil a little bit, but they're all about exactly the same height. So we can see that it doesn't matter really which orientation you put the kernels in. The roots know to go down, and the shoots know to go up. So the question popping up here is, what I give them is, what determines, or how does a plant know which way is up? So after introducing the phenomenon, I just asked my students what possibly could this be the signal that the plant is using and that the kernel is using to know which way's up. And these were, I teach high school, this is typically a lab we do in middle school, but these were what my high school students came up with was the light source, which is a good idea. Heat from the sun or ground, I guess you could do either direction there. Gravity, and I mean, they could come up with any number of explanations. So then I just had them come up with a way to test their hypothesis. So at this point, I would come up with several different hypotheses and put kids in groups, or allow them to pick which one they want to design an experiment to test, and then run their test, and then come back and report back to the group so they can see what happened. So again, I allowed my students to design some experiments, so I'll go through the setup for these. For the light, there were 2 different ways they could test the light, they thought. So in the kit, you get a pie tin, and just put some regular potting soil in there. And you also get some seed corn. And so I just have them plant them kind of from the center out in each direction, just from about halfway down. And temperature works better if it's above 60 degrees. I was trying to plant some of these to be able to show in the video today, and they were in my garage, and it was not warm enough, so they didn't germinate in the week that was there. So 60 to 90 degrees is good soil temperature for corn germination. You can have them plant as many as you want, but kind of get them to where they're spaced out a little bit. You can put some in between. Here, just make sure they get covered up. Add a little bit of water to that. You don't want to drown it. A lot of times I use a spray bottle, but if they look like they're sitting in too much water, you can poke a little hole in the side and set them in one of the clear containers to kind of catch some of the water. But you don't want them to drown, but you want them to stay moist during the germination. So they can do this and run several tests. Said the one group decided they wanted to put one in the dark, so they ran that and put another pie tin over the top of it. And then they did another one, and to control so it was open to the air and things, they put the clear lid over it and put a grow light over the top of that and let them see, you know, if they germinated and knew which way was up. Another group thought they wanted to try to see if they could get some to grow upside down, so they instead used the lid, the transparent lid that comes with your kit, planted their corn in that. And this is kind of creative. They put the aluminum foil pie tin on top and then used an aquarium so they could put this one on top, this one on the bottom, and I'll see if my grow light will reach in there. And then put the grow light in the middle, so the top container is seeing light from the bottom. So if they're growing towards the light, they were saying that the corn kernels in the top should send the shoots down and the roots up because they see the sunlight from underneath, and normally a plant wouldn't see that. So that's a good way to test to see if they were growing towards the light, because phototropism is the term for that, and that is definitely a thing in botany. Plants tend to grow towards light. So that was a really good setup for that. And the materials are pretty much there to be able to do that. You might have to come up with an aquarium, but most classrooms have one of those available. There's another setup in here. With the temperature, you could use an infrared bulb and do kind of the same thing to get from on top. There's the aquarium slide. I guess if you guys want to use the slides at this point, we can. There's also a Reptile heating pad that you can put underneath one to see if you can get it to grow up and down. They weren't real clear on whether they thought it was going to grow towards the heat or away from the heat. But again, that's just a variable that students can throw in there and test. Okay, the other thought is gravity. And this one's a little tricky for students to come up with as a way to change gravity, because most of the time when we experience gravity, it's pointed towards the center of the Earth. So we don't usually think of it as changing. So that's a little bit difficult for students to think about how they could change that up. But most of them have been on the gravitron at the fair or the state fair or something like that, where it spins you around and sucks you towards the side, and they can drop the floor out. So you kind of bring that up if they want to test gravity, and that is what is going to change the way their corn grows. So once they come up with the idea for a gravitron or start thinking about that, turntable is a good way to introduce gravity as a variable. So you take your corn kernels planted exactly the same way, and there's a little 3D printed pie tin holder that sits on the turntable. And so just plant it, put your grow light over the top of it again, and turn it on the highest speed possible. And if gravity affects this, the corn kernel should be feeling a little bit of, it's not gravity, but a force accelerating them towards the center. So they grow towards the center if that would be the prediction for that. So again, you have your control, and you're spinning one plate. Again, you see the corn kernels. The ones on the outside will get more force, so they'll grow more towards the center. The one in the center should grow pretty straight up and down. That's something they should kind of predict too. If it's, and you're set at 78, 75 RPM, again, the highest setting for speed there will make the most difference. And these were some that I grew. That picture isn't as pronounced, but here you can definitely see the corn plants on the outside are growing fairly strongly in towards the center there. The faster you can spin that, the more. The reasoning behind that, and this is good to have students look up, is that when the plant is growing, no matter which way the cells are oriented, there are hormones called auxins. It's a kind of a growth hormone that settles down at the bottom of the plant, and on the shoot side, it makes that cell wall here elongate, and on the root side, it does the opposite. It keeps it from getting long. So the cell starts to grow like this, the next cells go even further, and eventually they grow straight up and down. Now where that also comes into play is in selective herbicides. You see weed and feed or things for your lawn that have fertilizer and kill the weeds but don't kill your grass. Grasses like corn and lawn grasses don't tend to move these auxins around very much in their cells. Broadleaves weeds move it around a lot, and so if you spray it on the outside of the weeds, it'll cause them to grow like crazy. And that's what 2,4-D actually does, is gives these plants a lot of auxins, and they grow really fast and out of control, and they grow too fast for their nutrients. So that's how it kills the broadleaf, but not the corn or the grass that's in your yard. So it's kind of a cool tie-in. So that concludes the lab. To see more, visit kansascornstem.com.